Okay, so just a brief introduction to simultaneous equations, right? There are four main methods to solve simultaneous equations. The first method being the method of elimination. Second method, the method of substitution, right? These two methods are what we normally use in algebra to solve simultaneous equations. Third method is called the graphical method, or using graphs. And the fourth method is by using matrices. Right, so we need to know what are simultaneous equations. So a system of simultaneous equations, right, at the C-sec level consists of a pair of equations involving two variables, say x and y. Now we could use other variables, right? For example, a and b, or p and q, or s and t, and so on. So when we are asked to solve a pair of simultaneous equations, basically we are asked to solve for the two equations for the variables x and y simultaneously or at the same time. Right, so here we have a pair of simultaneous equations, right? So basically we're going to solve these two equations at the same time simultaneously to find the values of x and y. Right, so this is an example of a pair of simultaneous equations. So just a quick note, both equations in a system of simultaneous equations may be linear, right? So this word is very important, linear, where the degree or power of any variable is 1, right? Such as, so here we see the degree of the variables. If you look at each variable here, the degree of each variable is 1, right? So it's going to be 1, x power 1, y to power 1, x power 1 here, y to power 1, right? So once the degree or power of the variable is 1, then it's called a linear equation. So not all the time we're given linear equations. Sometimes we'll be given a pair of simultaneous equations where one equation is a linear equation and the other equation is a non-linear equation, right? For example, this is an example here where we have the first equation, 3x minus 4y equals 2. This is an example for a linear equation where the power of x and y is 1, all right? Or we could have a non-linear equation where the power of x is more than 1, or the power of y, or both of them are more than 1, all right? So a note here, in a non-linear equation, notice that the degree of power of at least one of the variables is greater than 1, right? So for this reason, it's called a non-linear equation. So if we have to solve a system of simultaneous equations involving only linear equations, meaning that both equations are linear, then we could use the elimination method, or we could use the substitution method. Although if you're using linear equations, then the better option would be to use the elimination method. It will be easier to use the elimination method. On the other hand, if we ask to solve a system of simultaneous equations involving one linear equation and one non-linear, then the only, or the best method, in fact the only method you could use, is the substitution method. Now in terms of the four methods that we talked about before, there's the method of elimination, substitution, graphical, and matrices. If we have to solve a pair of simultaneous equations where both equations are linear, right? So both equations are linear, right? So as mentioned before, we could either use the elimination method or substitution method. But we could also use the graphical method for when both equations are linear, or we could even use the matrix method when both equations are linear. So once we have linear equations, all four methods could be used. However, if we have to solve a pair of simultaneous equations where one equation is linear and the other equation is non-linear, right, then as we mentioned before, we could use the best method, or the only method was the substitution method, but we can also use the graphical method as well. Alright, so if we have one linear and one non-linear equation, right, then the only methods that are available are the substitution method and graphical method. We cannot use the elimination method, right, and we cannot use the method of matrices to solve when you have one linear and one non-linear method, one non-linear equation.